Line of the article I have read is Forecasting at Scale. This slide contains contents of the article. This slide contains headline, place, and time of origin, authors. Forecasting is a common data science task that helps organizations with capacity planning, goal setting, and anomaly detection. Despite its importance, there are serious challenges associated with producing reliable and high-quality forecasts, especially when there are a variety of time series and analysts with expertise in time series modeling are relatively rare. To address these challenges, authors describe a practical approach to forecasting at scale that combines configurable models with analyst-in-the-loop performance analysis. The authors propose a modular regression model with interpretable parameters that can be intuitively adjusted by analysts with domain knowledge about the time series. The authors describe performance analysis to compare and evaluate forecasting procedures, and automatically flag forecasts for manual review and adjustment. Tools that help analysts to use their expertise most effectively enable reliable, practical forecasting of business time series. Figure 1 shows a schematic view of the analyst in the loop. Figure 2 shows the number of events created on Facebook. There is a point for each day, and points are color-coded by day of week to show the weekly cycle. The features of this time series are representative of many business time series: multiple strong seasonalities, trend changes, outliers, and holiday effects. Figure 3 shows forecasts on the time series from Figure 2 using a collection of automated forecasting procedures. Forecasts were made at 3 illustrative points in the history, each using only the position of the time series up to that point. Forecasts for each day are grouped and colored by day of week to visualize weekly seasonality. Authors removed the outliers during plotting to allow for more vertical space in the figure. Figure 4 shows the profit model forecast to the Facebook events time series of Figure 3. These forecasts were made on the same 3 dates as in Figure 3 as before, using only the data up to that data for the forecast. The profit forecast is able to predict both the weekly and yearly seasonalities, and unlike the baselines in Figure 3, doesn't overreact to the holiday dip in the first year. In the first forecast, the profit model has slightly overfit the yearly seasonality, given only 1 year of data. In the third forecast, the model has not yet learned that the trend has changed. Figure 5 shows profit forecast using all available data, including the interpolation of the historical data. Solid lines are in sample fit, dashed lines are out of sample forecast. You can see that a forecast incorporating the most recent 3 months of data exhibits the trend change, dashed line. An important benefit of the decomposable model is that it allows us to look at each component of the forecast separately. Figure 6 shows the trend, weekly seasonality, and yearly seasonality components corresponding to the last forecast in Figure 4. This provides a useful tool for analysts to gain insight into their forecasting problem, besides just producing a prediction. Figure 7 demonstrates most mean absolute percentage errors for the forecasting methods and time series of Figures 3 and 4. Profit forecasts has substantially lower prediction error than the other automated forecast methods. When visualizing forecasts, the authors prefer to use points rather than lines to represent historical data, since they represent accurate measurements that are never interpolated. Then the authors put lines on the forecasts. For SHFs, it's useful to visualize the errors the model has made at various horizons, both as a time series, as in Figure 3, and aggregated over SHFs, as in Figure 7. Conclusion. A major theme of forecasting at scale is that analysts with a variety of backgrounds must make more forecasts than they can do manually. The first component of authors' forecasting system is a new model that the authors have developed over many iterations of forecasting a variety of data at Facebook. The authors use a simple modular regression model that often works well with default parameters, and that allows analysts to select the components that are relevant to their forecasting problem and easily make adjustments as needed. The second component is a system for measuring and tracking forecast accuracy and flagging forecasts that should be checked manually to help analysts make incremental improvements. This is a critical component which allows analysts to identify when adjustments need to be made to the model or when an entirely different model may be appropriate. Simple adjustable models and scalable performance monitoring in combination allow a large number of analysts to forecast a large number and a variety of time series, what the authors consider forecasting at scale. This slide contains references. PeerJ preprints is the venue for early communication or feedback before peer review. Thanks for your attention, and I am ready to answer your question.